Hello! Let's take a walk through some more SPSS output. This week we are looking at output from a two-way ANOVA. And the big difference between a one-way and a two-way is that a two-way has two independent variables. So when we look at our data, we've got two independent variables here. The first being training, and there is a group that has had no training, and there's a group that has had training. And then the second variable is your amount of life stress, and that is either low or high. So we have two independent variables that are nominal, so there's two groups within each, and then we have their performance, which is a count of how well they performed on a task. So again, that's going to be at a ratio or interval level. And so that meets our requirements for doing a two-way ANOVA. As we look down our output, again, we have descriptive statistics. And we see our mean, median, mode, standard deviation for our performance. And remember, we're not going to report our statistics for the nominal variables. All right, moving on. Again, we've got continued looking at then separating out our groups, the mean performance for our no training high stress, our no training low stress, our training high stress and training low stress. You probably just looking at these numbers are starting to get an idea of what might be going on here, but again, we want to run the statistics and see what's going on. So before we get to those inferential statistics, though, we want to cover all the bases in terms of our descriptives. So we're going to go down to our graphs. There's a lot of output here, so just keep going through. And here's our graph of performance. This looks almost this is pretty non-normal, right? There's not one big peak. We've kind of got two peaks. They're not really equal, but it looks like we've got some different groups going on here. I would call this bimodal. And it's tough to judge whether something is skewed or not when you have bimodal distributions. So it's okay to say that skew is difficult to judge because of the bimodality. So given that, let's go down and look at our ANOVA. Now the big thing about a two-way ANOVA is that there are three hypotheses that you are testing. You are testing a null hypothesis for each of the independent variables and one for their interaction. So for training, you would say that your hypothesis is that the no training group equals the high training group. For life stress, you would say the low life stress group equals the mean score of the high life stress group. But the interaction means that there's combinations. So maybe people who have low life stress benefit more from training. Maybe people who have high life stress benefit more from going to training. That's the interaction. So that's written as the mean of the no training low stress equals the mean of the no training high stress equals the mean of the training low stress equals the mean of the training high stress. So all four of those means would be equal to each other. And that hypothesis is the first one we're going to look at, because if that's true, then we actually almost ignore the other independent or the main effects, because the interaction overrides them. So just like before, we're going to look at this significance column, and here we see our level of significance for our interaction is 0.187. So we compare that to 0.05. If it is higher than 0.05, we would reject we would accept the null. And if it's lower than 0.05, we reject the null. Now, as I said, we want to look at this interaction first. If it is significant, we kind of ignore the other things. If it is not significant, we would look at the other variables. And obviously 0.18 is greater than 0.05, so we're going to go ahead and look at the individual main effects. And main effect just means the effect of each independent variable separately. So when we look at life stress, we see, oh, that is just about equal to 0.05, just slightly less, and training is less than 0.05. So what does all this mean? Sometimes I find that actually looking at the graphs helps me figure this out. So when I look here, these lines are pretty parallel to each other, and that's another indication that there's probably not an interaction. So people in the low stress group are in green, and they went from pretty low. The people who were low stress and got no training had pretty low performance means. The people who were low stress and got training did a lot better. And we see the same pattern with people who had high life stress. They did a lot better with training too. So what that tells us is there is an effect of training. And we also see that the low people do consistently better than the high stress people as well. So those are our two main effects. They are the results of those two hypotheses, one about life stress, one about training. If there was an interaction, we might see that this high stress group, for instance, the line would just go from here to here. Like they would start off high and they would end high. Or maybe it would be way down here. Maybe after training they would still be low. And that would tell us that that training had a different impact for the high stress group. That's what a significant interaction would look like. In this case, we don't really have one. Now finally, remember those post hoc tests that we talked about in the ANOVAs. To ANOVA, we need to run a post hoc, right? No, because remember, post hocs are for when there are 3 groups and we need to see which pairs are significant. In this case, there's fewer than 3 groups in both of our variables, so we know that where the significance is. It's between those two, training and not training, and it's between high stress and low stress. So I know this is complicated. This is a pretty complex piece to figure out this interaction, but let me know if you have questions.